Okay, so now that we have a little bit of a basis or foundation for understanding quantitative relationships and solutions, specifically in terms of concentration, let's apply that now to a concept that we saw earlier on, which is our acids and bases, and the terminology that we use to describe acids and bases, which is something called a pH scale. So we're going to talk a little bit about where pH comes from and how we calculate it. So the pH scale, and again, pH here is abbreviated small p, big H, right? What this is, and it's defined actually, the pH is defined by an equation, which is the negative logarithm, so negative log to base 10, of the concentration of the hydronium ion, H3O plus. Okay, or sometimes a pH, in order just to save time, it's written as a negative log of just the H plus, the proton concentration. Remember, H3O plus and H plus are essentially the same thing, right? One is just used just for simplicity's sake. So we can calculate this thing called a pH, which depends on the concentration now, the square brackets of the hydronium ions, or just the concentration of the proton in that solution. So if we know what the hydronium ion concentration is, we can simply stick it into this equation. We can calculate the pH. So for example, if we're looking at pure H2O, pure water at 25 degrees Celsius, what we find is that the concentration of the H3O plus, the hydronium ion, this is a typo here, is 1.0 times 10 to the negative 7 molar. So if I were to take this now and calculate the pH, well, the pH would be the negative log of that 1.0 times 10 to the negative 7, and this gives me a pH value of 7.00. There are no there are no units for pH. Okay, it's just a number, and that number ranges from typically from 1 or from 0 all the way to 14. And then we'll see some other examples of pH values when we get into general chemistry 2 a little bit later on. So something with a pH of exactly 7 is considered neutral. So exactly 7 is neutral. Anything greater than 7, so pH greater than 7.00 is considered basic. Another term for that is alkaline. And any pH less than 7 is considered acidic. Okay, and that's the pH scale that we want to be concerned with. So if we can determine the pH of a solution and we get a number, we just match it up to our pH scale. We can say really quickly whether a solution is acidic, whether it's basic, or whether it is neutral, as long as we have that H plus or the H3O plus concentration. So here are some pH values of some common everyday substances. Some may surprise you, some may not be as surprising as others. We talked about pure water before, having a pH of exactly 7, so that's considered neutral. Okay, and what we see, for instance, something like lemon juice has a pH of 2, so that's moderately acidic. Stomach acid, the acid in your stomach is very acidic, pH of 1. We have different, other types of juices, orange juice, grapefruit juice, also moderately acidic. And if you look, for instance, now at the pH of blood, right, it is not neutral, and that's important because if blood were neutral, you would die. It is actually on the basic side, and it's slightly basic. Okay, it hovers between 7.35 and 7.45, and it needs to be in that range so that all the stuff that is in your blood is able to function effectively. So we can calculate our pH values simply by using the pH equation, the negative log of the H3O plus or the negative log of the hydronium or the proton concentration. What we can also do is in some cases we can measure the pH of the solution, and from that we can determine the concentration of the H3O plus. We just have to know how logs actually work. So for example, if the pH is measured instead of being calculated, we can use that to calculate the concentration of the H3O plus by using the following. So we can say the H3O plus concentration for a solution is simply equal to 10 raised to the power of the negative pH. All right, so for example, let's see option C here. So if the pH is measured with some device, like a pH meter, for instance, the pH is 8.01, we know that's basic, then the concentration of the H3O plus is simply equal to 10 raised to the power of the negative 8.01, that's a negative pH. Stick that in your calculator, and that's going to give you 9.8 times 10 to the negative 9 molar. So what you will see generally as you work with these is that the H3O plus, the hydronium ion concentrations, right? These tend to be very small values, not always, but generally. Okay, whereas your pH numbers, okay, they typically range from 0 to 14. So they're much larger um, in magnitude compared to the H3O plus. And again, uh, they they differ dramatically because the pH scale, right? It's not a normal scale, it is a logarithmic scale, right? So it relates, in this case, logs are used to represent or to convert really big numbers to numbers that are a little bit easier to work with, or in this case, it converts really, really small numbers into a form that is easier to work with and to manipulate.